With the 60th example, and here it is said that in the arrangement of figure 1.9, the masses m0, m1, m2 of bodies are equal. So m0, m1, m2, they are equal. Say for easy purpose I am taking them as m. The mass of the pulley and the thread is negligible. There is no friction in the pulley. Find the acceleration w with which the m0 comes down. So we need to find the acceleration with which m0 will come down, as well as we need to find the tension in the thread. So let us suppose here in this thread tension is T1 and in this thread tension is T2. If coefficient of friction is K, consider the possible cases. Okay, let us suppose consider the first possible case is that the weight m0 g is less than the friction between m1 and m2. So if m0 g is less than between m1 and m2, then the acceleration of the bodies would be 0 and the system would be in a state of rest. That is the first case. Now let us consider the second case when the m0 g is greater than the net friction, that is friction on body 1, friction on body 2, maximum static friction on body 1 and 2. Then in that case it will come down with acceleration, the system will come down with some acceleration. So in such a case we will consider this as a system and the external forces acting on the system, and we can find the acceleration. So we know that acceleration will be equal to net force upon net mass in the system. So acceleration would be, net force will be m0 into g minus frictional force on body 1 plus frictional force on body 2 upon 3 times of m0, that is m plus m plus m. Let the masses be, all masses be suppose m0. So m0. So I can say acceleration would be equal to m0 into g minus frictional force. So we know that the frictional force is nothing but mu into n. So here coefficient of friction is k and weight is m0 g, while here it will be mu to n2. So it will be k into m0 g, as m1, m2, m3 they are equal. So I am writing this all in terms of m0. So it will be k m0 into g plus k m0 into g divided by 3 m0, that is m0 m0 m1 m0 m0 plus m0. So acceleration will be equal to m0 into g twice of k m0 into g upon 3 m0. So acceleration would be equal to, m0 can be taken as common, it will get cancelled, g can be taken as common, so it will be g in bracket 1 minus 2k upon 3, and that's the acceleration of the bodies if the weight is greater than the friction. Also we need to find the tension in the thread. Okay, so tension in the thread can be found by drawing the FBD. Let us suppose I am drawing the FBD of suspended block m0 g. So the weight m0 g is acting in a downward direction, tension is acting in the upward direction, it is coming down with acceleration. So I can say T minus m0 g is equal to m0 into acceleration. So T will be equal to m0 in bracket g plus acceleration. So it will be m0 in bracket g plus g in bracket 1 minus 2k upon 3, and on arranging you can get the answer. m0 into g, it 3 will be 3 plus 1 minus 2k upon 3. So tension T1 will be equal to m0 into g 4 minus 2k upon 3. So that is the tension in string 1. Similarly, by drawing the FBD of the M2 block, let's draw the FBD of M2 block. So T2 will be acting in this direction and friction will be acting in this direction, and it is going with acceleration in this direction. So I can say T2 minus F2 is equal to mass into acceleration. So T2 minus F2 k m2 into g is equal to m2 into a. So T2 would be equal to m2a plus k into m2g. So m2 in bracket, a is g in bracket 1 minus 2k whole divided by 3 plus k into m2 into g. So m2g can be taken as common. So it will be 1 minus 2k upon 3 plus k. So it will be m2 into g in bracket 1 plus k upon 3, and that is the tension in the string 2. These are the answers. While in the first case, as all the system is in rest, so tension will be equal to T1 will be equal to T2 will be equal to, that comes out to m0 into g. Everywhere the tension will remain same because the forces will balance each other. Okay, that will be the answer to this question. So thank you.